Hello and welcome everyone. I'm Nathan Pomart and this is Loose, the Climate Tech Podcast. Every week we interview a founder and explore the stories, ideas, innovations and businesses behind some of the most inspiring climate tech companies that have a tangible positive impact on our planet. This show is designed to help you learn, instigate optimism, and inspire further action towards addressing the climate change challenge that we face as a global community. If you are an entrepreneur, business leader, or investor interested in learning more about the climate tech space and how you can play a part in it, this show is for you. My guest today is Scott Graybeal. Scott is the CEO of Caelux, Pasadena, California-based developer of perovskite-based solar technology. Caelux has developed a technology that improves the performance of any solar module by more than 30% by applying to them an additional layer of nanomaterials. This additional layer absorbs sunlight better and enables manufacturers to make solar panels that convert more sunlight into electricity. This ultimately drives down the cost per unit of energy produced. Caelux recently completed a $12 million Series A from Reliance New Energy Limited, the climate tech-focused subsidiary of Reliance Industries, one of the largest companies in India by revenue and market cap. A veteran executive with more than 2 decades of experience in the solar industry, Scott joined Caelux to drive scale and commercialization of their promising perovskite-based technology. This is the focus of our discussion. In this episode, you will learn about what perovskites are and how they are fundamental to help reach solar adoption goals. What are the outstanding challenges in this space and how Caelux is addressing them? And why they are partnering with Reliance New Energy to accelerate their speed to market. I hope you enjoy my discussion with Scott Graybeal. So Scott, welcome to the show. I'm very excited to have this conversation with you. Innovation in solar has been happening at a very fast pace, and you have been at the forefront of it for a while now. So I'm looking forward to diving into this topic. Welcome to the show.
Well, thank you very much, and thank you for having me.
Scott, let's start with you. Tell us a bit about your story and how that led you to getting involved with Caelux.
I've been involved in solar since about 2008, but my first career was as a nuclear submarine officer in the U.S. Navy for about 5 years in active duty and about 5 years in the reserves. I started in the semiconductor industry and then moved into data storage and then found my way into solar in that time frame, and had been on the capital equipment side of things for a while, did some time as a project development person, and eventually ran the energy business at a company called Flex, or formerly known as Flextronics. And we grew that business from about $300 million in revenue to about $2 billion, and made some key innovations in solar manufacturing along the way. And that was my experience in really running an energy business at scale and what that meant. So we had worked with all of the different inverter manufacturers, solar manufacturers, very early in energy storage. I did a couple of strategic acquisitions along the way. Most notably was Nextracker, which was now the largest single axis tracking company in the world. And it started when we purchased the company, it was about $45 million in revenue. And they're well over $1 billion today with about a $3 billion valuation. Acquired AI companies as well to support the energy business. And so I've had a pretty broad background. And at the time I was looking to actually move more into the venture world. And I had been at a startup previously prior to coming to Caelux, but I wanted to get on the investment side. And then I got a phone call from Khosla Ventures, and they asked that I take a look at this company called Caelux a couple of years back, and never looked back. The company really was making some tremendous progress in this new and emerging field that we call perovskites. And that has really allowed me to kind of apply my skill set to a company that had fantastic ideas and a great innovative platform.
So for those listening who may not be as familiar with the different, I would say, technologies that come into solar panels and where perovskite fits in, could you paint a picture of the context around this new technology and what perovskites-based technologies do?
Certainly. When we talk about perovskites, we're talking about a family of materials that have a specific crystal structure. And there's lots of varieties of perovskites. It's not the mineral that people normally think about. They'll talk about calcium titanate. That's where it started. But the materials that we're talking about have the same crystal structure as that mineral perovskite. And so they got the name perovskite once they were really understood and properly characterized. But what they are, it's just a mixture of metals and nonmetals when combined in certain ways produce very effective solar cells, very powerful solar cells, and with very low cost precursors, very low cost materials that are needed. Nothing that would be considered a rare earth mineral, for example. And so they have a tremendous future insofar as that you can have very high efficiency solar cells that can be made very inexpensively.
So what are they made of compared to the, let's call it, the traditional way of making solar panels that relies on, as you mentioned, rare earth?
Well, traditional solar panels, they tend to use a lot of, I would say, readily available materials, but the challenge that they have is the thermal requirements. You have to mine quartz and melt it down, produce polysilicon, slice it into wafers, and then attach it and treat the silicon in a certain way with special processes, and then attach all these cells together to create a solar module. And it's been around for a very long time, very reliable, good performance coming out of silicon. But in terms of headroom in the technology, it's getting harder and harder to squeeze more performance out of silicon. That what we use are largely organic materials mixed with some metals and readily available metals, such as lead, as an example. And so when you're able to mix these materials together, you can get some cells that perform very well and can be produced very inexpensively. We have no high temperature processes in our system, as an example. So we don't need to melt anything and then make ingots of something and slice up the metals, etc. These are materials that flow very easily and can be deposited using fairly conventional methods. And that's been part of what Caelux's approach has been, is let's use low cost materials, let's use largely standardized capital equipment that supports other industries. So these are things that we can readily grab off the shelf for the most part and produce these materials at scale. And our architecture for our product, and Caelux is not a solar module company, I should be careful about that. What we do is we improve the performance of traditional solar modules. And so crystalline silicon modules, they can produce quite well. You know, you see modules that are between 22, 23% that are in production or available for sale today. What we can do is enhance the performance even further. And this is important because it's getting more costly for folks to actually improve the performance of crystalline silicon. And there's some would say that, gee, do we really need to? Well, the reality is that in the US, we have a target to have 40% of electricity produced by solar by 2035. And globally, there's a lot of talk around having half of the global solar production coming from solar by 2050. In order for you to really do that, you have to drop the cost of solar modules by about 2/3. And that's very difficult to do using the current silicon architecture. So you have to start looking at different approaches. And so our view is, gee, let's go and commercialize perovskites by leaning into the strengths of silicon, and silicon in turn takes advantage of the strengths of perovskites and create a product that can be commercialized relatively quickly. And this way we learn a lot about these materials by producing them at scale. Our view is that we turn potential competitors with the crystalline silicon world into customers. And so we're compatible with nearly every solar module type out there.
And so let's dive into this, specifically into who do you interplay with in the solar panel value chain. Quite interestingly, if I understood what you mentioned right, your customers are, let's say, the existing uh, solar panel manufacturers. Is that correct? And maybe as you answer this question, it would be interesting to understand for those less familiar with it, the broader value chain of, basically all the way down to people who will install solar panels and coming back up to the companies that you interface with to bring your solution to market?
We're not too far away from the person who's installing the solar modules, whether they be a home installer or a project developer or an engineering procurement and construction company. We work directly with solar module companies. And so our business model is that we consign glass from module companies and we deposit our material system on that glass. And then we return the glass to the module company. And then they're able to put that in production much like they would any other solar glass with very few process changes that are needed on their side. And so there should be no capex that they need to invest in order to use our product, and they can connect it largely the same way that they would a standard solar glass, with a couple of small exceptions. And that enables them to leverage the investments that they've already made. And so whether it be a low performing solar cell array or it could be a very high performing one, what we do is provide a performance boost to whatever architecture that we're working with. And Caelux's IP is around this we call it 4-terminal hybrid tandem module architecture, where our glass is placed in parallel to the electrical circuit of the bottom cell array. And by connecting them in parallel, we don't have issues with current matching. We have to match voltage, but our perovskite formulation actually matches silicon quite well. And so we can passively connect our solution to the customer's cell or module architecture and provide a significant performance boost, be 30% more power. That would be indicative right after the module's manufacturing, about 20% more energy harvest over a 25-year life of a project.
And without going into obviously the secret sauce of your company, could you help us understand what did you have to crack technologically in order to make what you're selling today possible? And maybe as you do that, walking through the history of the company, which started in 2014, when did you make the breakthrough technological uh, innovation that enabled you to be where you are today?
I'm not a big believer in massive breakthroughs. I think the breakthroughs come very early in a product's, let's say, introduction. The breakthrough, I think, really was happening all over the world with the discovery of these materials. What really becomes important is how you leverage these and learn from your various iterations as you experiment your way to a product. And so the challenge you have with any product is you have to balance a number of parameters for it to be, let's say, marketable. And for us, it's really been balancing scalability, efficiency, and durability of these materials. And that's really been our focus. If there was any breakthrough, so to speak, it was really in making that transition from research and development into a product company. And once you start thinking about things as a product, it begins to evoke a series of disciplines that you have to be very good at, not the least of which is making hard choices about technology. Working with technologies and systems that are expensive, and you can be quite expensive in manufacturing perovskites if you choose to be. But if you don't have that as a design constraint because you're thinking about what scale looks like, you're going to go down the wrong path. And I think by putting that constraint on our team and saying, look, this has to be scalable, this has to be made with low cost precursors, it has to be sold at a price point that is not going to impinge on the cost per watt for our customers, really pushes you in a different direction. And we had to be very thoughtful and aggressive. We don't have a sunk cost fallacy at Caelux. If we find that something doesn't work, we will kill a program or an approach and move on to the next thing. And that's some of the early things we had to do. So Caelux started, as you mentioned, 2014. And it started with some technology that came out of Caltech. It turned out that technology really wasn't viable for the application, but the company had always started with the idea that we could improve the performance of crystalline silicon. And so that had evolved over the years. And about 5 years ago, going on 6 years ago, we made the transition to perovskites. We were watching closely the research and seeing how these materials were performing. And when they were first invented, they always had great performance from an efficiency standpoint, but you could literally only walk a couple of meters to the next test station before you would start seeing things degrade. And so that has changed, obviously. We're seeing perovskites, even our own perovskites can last multiple years in an operating environment. So while durability still remains a challenge, it's more of an engineering challenge, and I think it's than a physics challenge. And so, what we've been able to do and what we have done is we pushed very early to move away from lab scale substrates and move into prototype phase that forced us to look at what techniques we had to leverage in order to make these technologies scalable. Everything from our transparent conductive oxide deposition, which is basically a fancy word for a conductor you put on the glass, to how we built up the stack and the techniques we used to deposit the perovskite, and all the way through the connection scheme and how it would connect to the bottom cell array. And so it's been more a function of learning rates and grinding than anything
Hmm.
else. And that's really been the purpose of this investment that we received from Reliance Industries, is really taking the company to the next level where we can start producing at pilot scale on full module size form factors. And so today we do everything on an 8-inch by 8-inch substrate. And the pilot manufacturing line by next year is going to be able to produce things on a 1.5 square meter substrate. And so that's really the direction that we're headed. And we'll have our minimum viable product, first minimum viable product threshold be achieved late next year. And we'll have a full release product by the end of 24.
And who are the talking about the customers that you engage with
Mm-hmm.
to iterate on your minimal viable product? What is the alternative that they are having to decide between going with you or doing something else? What is that something else? It's basically not improving the performance of their existing solar modules,
Yeah,
or it's going for different
I
technologies.
think you can. Yeah, it's an interesting way to think about it, because clearly somebody can run in place and decide they want to look at their operations as being a cash cow. The other approach is you continue to invest in the current state of the art, which is continue to invest in silicon. And absolutely, people should still do that. Companies who want to be relevant really need to continue to do that. But what we provide is an enhancement on top of it. And so I guess ultimately you could say, what are the options in perovskites that may be a place? But we feel we're pretty far ahead of the curve in terms of productization of our approach. So we become a pretty obvious choice for a number of module companies. But in particular, we announced the strategic agreement with Reliance, which is, REC is their subsidiary in the solar space, and we'll be partnering closely with them as we launch this product, as well as others.
Are you planning to do the manufacturing yourself? So when you refer to the pilot manufacturing line, is that something that you're going to be doing internally, or that you're going to be doing with a
And that's something
partner?
we do internally. So what you can think about our operations, I mentioned before, we consign glass. So that effectively means that instead of the glass being shipped directly to our customer, it comes from the glass factory and goes to our factory first. And then we transform that glass into another set of solar cells. So that's proprietary manufacturing that we've developed and will continue to develop in this pilot line. So that'll be done inside the four walls of Caelux. But the treated glass is then shipped to the module manufacturer, the module assembler. We'll be starting a development site here in the LA metro area, not far from Pasadena. We sit in Pasadena today. Um, and the intent is to go and develop all of our processes here. And then as we expand and we build out more manufacturing locations, we have a copy smart mindset where we'll take the things that work, know that work, and then bring up the other satellite manufacturing locations um, up on that same process node. And so we have a system that we've developed that enables that. And so we have an organization structure, though we're small today, but we have the framework in place that enables us to go and scale other manufacturing operations. And you can surmise from how I described our business model, it makes sense for us to be close to either the glass manufacturer, the module company, or a major logistics node through which the glass probably transits first.
Yes.
And we're fortunate here in LA metro area. The largest port in the United States is the Los Angeles harbor here. So, this is the gateway for many products coming from Asia in particular. And so for us we're very close to that location. And so we've satisfied, I think, one of our operating requirements, but we'll have about 100 megawatts here in the LA metro area. And that's an important consideration for us, because our next expansions will probably be on the order of 500 megawatts plus. And you think about the expansions happening at 500 megawatt blocks. But it's important for us to be in this area, and it's a strategic decision based on proximity to some of the top universities in the world. We have a
Yeah, because your team is largely people coming from those top
correct.
universities.
That's correct. Yeah.
Mhm.
So
Tell us a bit more about the I would say, I was going to say skills, but it's more than skills. It's level of command of certain very niche and advanced scientific disciplines that you're looking for. So which ones are
Well,
those?
clearly you have to have some people that really understand perovskites, organometallic chemistry, deep understanding of the underlying physics of these devices. And so that's something that we've been able to build up as part of our research and development organization, from our founder, John Iannelli, all the way through the rest of the R&D and engineering organization. And you have to find people that also have experience on the downstream side, so they know what customers expect when it comes to technologies that improve the performance of modules. And so we've been able to build that out both with our head of R&D and our head of engineering. And folks can look at who they are on our website, caelux.com.
Sure.
So that's key, that you're able to go and tap into those people and would have that motivation and that insight that they can bring through the experience that they have. While Caelux has only been involved in this part of solar for about 5 years, the people on our team have been involved in this particular field for more than 10 years, back before they were even referred to as perovskites. So we have a deep bench of experience, and we continue to bring people into the organization that may not have direct experience with perovskites, but know the fundamentals and can be trained and learn. And so we're most excited about some of our new employees that come and join the company that have the determination and energy that we really would love to see in the team, that are ready and willing to absorb. We have a pretty broad spectrum of folks on the team, all the way from new college graduates from a bachelor's program, all the way through PhDs, and all the way through industry veterans that have been in solar for quite some time and have seen the challenges and have learned from them.
You've mentioned the strategic partnership earlier with RAL. Sorry for my slow pronunciation. It's a pattern that I've seen in many companies trying to innovate in the climate tech space. Can you tell us a bit about the logic for entering into this partnership? What are the synergies? What does it bring you to partner with a much bigger group, and what can you bring
Well,
to
we're
them?
very proud to be working with REC, and I've worked with REC since about 2008, when I first got into the solar industry, and in various different ways. And in one company, we had invested in the same company they had, and we eventually acquired that company in the equipment space. And I've known them for a long time. They have a fantastic reputation, both as business people as well as technologists, and I think they make some of the best products in the world. And it was really our number one to work with. And so when we were able to
Hmm.
make that transition from customer, would you please test out our samples, to how do you feel about working more closely with us in the context of an investment and strategic partnership, they were very willing and very ready. And I think that what was helpful for them as well was the fact that Reliance had acquired REC, and that gave them even more resources and a larger market and a much bigger addressable market for them to attack. And I think we found that we could solve each other's problems. And that's the best foundation for a partnership I can imagine. You have a requirement, we have a requirement. How do we go and make it work? And so that's exciting for us. And I think anytime a smaller company partners with a bigger company, the smaller company can gain a lot, just in terms of not just credibility in the market, which we feel is huge, but also the fact it teaches you to be a better company. And that had been my experience all
Mhm.
throughout my career. I'd worked with larger and smaller companies, and you have to be able to learn from all of them. So it's one of our favorite dimensions of this. It wasn't just an investment. It really was about how can we go and find a commercial on ramp for which we believe is a very, very exciting basket of technologies.
And to put it simply, what are their problems and what are your problems when you say we can solve each
Well, I
other's
think my
problems?
problems are probably the same as everybody else in this space, where it's like, how do you find customers? First and
Hmm.
foremost, and to be honest, it has been a key pushback when I've talked to financial investors. Like, gee, they would come at our company more from the perspective of legacy thin film solar approaches, and that's clouded, I think, a lot of people's judgment. And we would talk about the ability to enhance performance, and until a tier one solar manufacturer stands up and says, yes, we believe this is the case, um, it's hard to do.
Yeah.
And I think that's something that we've been able to secure, through this investment slant strategic partnership. And I think any solar company, any module company is going to be looking for the most cost effective path to improve their product and to drive differentiation. And so I think that's an important consideration for any company. I really can't speak, to what specifically they envision, but I could say that the approach that we're looking at here melds very well. We want to make solar better. They want their solar to be better. Let's go and make things happen. And they're working with us
Yeah.
on all the durability testing and what they have to go through themselves with any new product release. And that's something I've made a lot of modules over the years for a lot of different companies, and so I was familiar with much of it. But it's eye opening when you get to really see, oh, okay, how does this test really kind of interlace with that, and what special testing do you do on top of what's the normal IEC testing, and how do we think about bringing this product to market in such a way that it actually delivers value? And that's been great. And no, we really appreciate that foundation that we're able to build with them. And as I mentioned, it's important. We're able to work with others, but I think that um, we like working with them. It's been good from that standpoint. It's been great to really work closely with them and continue to do so.
What do you intend the $12 million that you raised through this partnership to be used for? Speaking broadly, what are going to be the key
It's going
areas
to
of
be ramping
investment?
up this pilot line. Calyx was fortunate that we owned a number of assets already that would support the build out of this pilot line, particularly the large PVD coders that we need, the laser scribing tools. And so we have a little bit of capex we need to invest in, but it's not a ton relative to what it would be to start, for somebody brand new to come into it. So we were able to risk mitigate our capex requirements. So a lot of it's going to be
Yeah,
around the staffing needs that we have to ramp production and to get to the Calyx One launch, which is really the focus for that. And Calyx One is our
got it.
first product.
Um, Scott, as we approach the end of this interview, you've been in the industry for a while, before Caelux and at Caelux. Um, what is the thing that surprised you most in this new venture that you had to, you know, I guess that you discovered, and you had to work out a way to adapt to this surprise?
Um, I wouldn't say much of it was surprising from like a business execution standpoint. I'd seen a lot of it before.
Okay.
And so for me, it's been about applying lessons that I have learned the hard way in some cases, and in some cases, not so
Hmm.
hard. But that's been relatively straightforward. I would say that I would say, disappointed in some ways, more about the perspectives that so-called, and I'm probably going to get some heat for this, but I'll say it anyway because I think it's important that people begin to really wake up. I would say the approach that many quote unquote green tech investors take, and um,
Mm.
I I would
What
say
do you
that
mean
there's a
by that?
handful that are truly visionary, and I would put Khosla Ventures in that basket. In fact, I consider him probably the most visionary of financial investors out there, and they had supported the company from day one, and they clearly saw something. And it was a bit of a challenge sometimes to communicate that to other financial investors about what the promise of this technology really is. So we got a tremendous amount of validation through that relationship with Reliance and a tremendous amount of support from Coastal Ventures over the years. And we're very grateful for both. So I think I was most surprised that it was difficult, how difficult it was really to convince folks that, look, this is something that is going to be transformational. And our friends at Reliance and REC got it pretty quickly once we achieved milestones.
What do you think? What do you think the skeptics missed? Because I think there is a broader pattern here of investing in climate tech companies and in transformational ones requires to look at things maybe differently from what the venture industry has learned to look at things, in other, let's say, sectors where they have been where the industry has been successful in the past. So it's interesting to hear from you. What do you think people missed? Maybe things where you 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 would think they maybe could have leant forward more given the information that was available.
I think there's not enough independent thinking. Truthfully, I
Mm.
think that there are trends that people, and we're social creatures, we tend to, this fear of missing out is a very big thing. And I could see that there was an explosion in the hydrogen, not to you say that, but there was truly an explosion in hydrogen investment, the tremendous trend. Same thing in carbon capture, which are great technologies. I don't mean to disparage that. But we used to joke last year, the joke was we could change the company to Caelux Hydrogen and we'd probably have 8 term sheets. and
Right.
and
Yes.
unfortunately, I had seen that trend before in solar, and solar, the same thing in that 2007 to 2009 timeframe, was very much the same way, and I'm sure people in other industries were probably joking
Hmm.
about the fact
Hmm.
they had to change their name to Sox Solar, and they would probably, have a
Yes.
massive IPO potential. And it's unfortunate that sometimes there's a lot of frothiness that's created where there's a level of desperation. It's likely being pushed by other folks in the value chain of cash that comes to the table to go look at these things. Oh, that hydrogen thing looks really cool. Exxon invested a bunch. Shell invested a bunch. Well, we can't go wrong if we go side by side with them. And that's I can understand that, right? I'm not trying to disparage anybody. I'm sure there's a ton of pressure to find those deals when they become relevant. And I think solar has
Correct.
had a bit of a hangover from companies that really struggled. And some of them made it. First Solar is a runaway success of that same time frame. And other companies were runaway successes. You can see the massive success of the Chinese solar industry is just an example. But oftentimes, I think companies in our space are struggle with the thin film solar hangover, I'll call it, where investors had put money
Yes.
into a SIGs company and that didn't work out. And they invested in the team, but they didn't really do a hard enough look at the technology. And your fundamentals of the technology need to
Yeah.
be solid. And I think that's one thing that we've learned. And in the perovskite space, there's a ton of support from outside laboratories, from outside investigators and researchers that have been able to show the promise of this technology. But trying to get folks to wrap their head around yet another innovative solar approach is a bit difficult. And part of it has to do with history, and some of it has to do with just that it's not a hot trend. And so we're hoping that with this investment that we receive, we're hoping to help change that. Now that we have a large tier one strategic player that's behind the company, that maybe that there is something here. And I think that there's very smart investors, or very
Hmm.
savvy
Hmm.
investors, and they'll hopefully that helps to. And we have a lot of attention right now on our subsequent A2 round. We had an A1 with Reliance, now we have an A2, and so it's good to see. I think that was a.
Can you share already
No,
who
that's
is in the
confidential,
A2?
unfortunately. Yeah.
Or okay, we'll save it for the next interview
Yeah.
then.
After it's closed.
Look, thank you so much for taking the time. It's been fascinating to go into this very advanced new space, and I wish you the best for the round that's coming and for the uh, pilot manufacturing lines. And I hope to see you soon again on the show.
Well, thank you very much. I really appreciate the opportunity to talk about our company and wish you the best.
You can find out more about Caelux on their website, caelux.com. If you enjoyed this episode, please follow up on your favorite podcast app and stay tuned for more insightful conversations with some of the most inspiring climate tech founders.